Welcome to Canara Engineering College, Department of Mechanical Engineering. Today we are going to discuss about the terminologies that is used for a transducer. In the previous lecture, we have discussed up to 4 terminologies. Let us continue with the further terminologies which is associated with a transducer. Okay, the non-linearity error. Now, what is this? It's obviously an error which is associated with the transducer. Now, what is nonlinear error? To understand nonlinear error, let me put it in this way. We generally assume that whatever input we give, for that, the corresponding output we get. So, for every input, there is a corresponding output, and this input and output characteristics, we assume it to be linear in nature. But this assumption itself is wrong. The assumption that input and output characteristics are linear in nature is a wrong assumption, and that itself leads to an error which is called as a nonlinear error. So there are actually three ways in which we can measure the nonlinear error. What are they? The first one is called as the end range values. In end range values, the error is measured from the starting point and the end point. So whatever you see over here, this curved line or this particular curve is the true value reading. And if I try to draw a linear line from the starting point to the end point, there is a gap between the true value recorded and the linear values that is recorded. Now this particular gap or this particular difference is also called as a nonlinear error. Then the next method is called as the best straight line for all values. So this similar curve is present over here. That's the same curve which is drawn. Now instead of drawing a linear line from 0 point to the end point, if I try to draw a linear line which will somewhat try to fit to the curve, then that method is called as the best straight line for all values, and there also we can find an error gap which is called as a nonlinear error. The third method is called as the best straight line through 0 point. Here also you have the same curve, and to this same curve, instead of drawing it from one end point, start point to end point or best fit curve, you take the start point as 0 and try to draw a line which will somewhat match with this particular curve. Then such a method is called as the best straight line through 0 point to determine the nonlinear error. Next terminology is called as repeatability or reproducibility. The term itself describes its meaning. Repeatability means it is able to repeat the result again and again. If at all a sensor is able to produce the same output for repeated application of same input, then we can tell the sensor is having good repeatability or reproducibility. The next terminology is called as stability. It is the ability of a transducer to give the same output when used to measure a constant input over a period of time. So if I can tell it with an example, in case if you are trying to measure 1 kg of a quantity, for example 1 kg of rice, you keep it on a weighing machine and keep it on the weighing machine for more than 10 minutes. The reading that it showed 10 minutes earlier and 10 minutes later should be the same. If it gives the same reading, then we can tell that the instrument is stable. So the next important terminology is called as stability. Then we have something called as dead band or time. What is dead band or time? It is the length of the time from the application of an input until the output begins to respond and change. So if I apply some particular load to an instrument and the instrument start giving me the output, that time band, the application of load to giving an output, that time band is called as the dead band or the dead time. Then what is the meaning of resolution? Resolution means it is the smallest change value of input that the instrument produces an observable change in the output. To understand the concept of resolution, I'll give you an example where you are measuring a quantity. For example, you are going to a grocery store, and in that grocery store you are trying to measure 1 kg of sugar by using a gravity type of weighing machine. So in that weighing machine, you will put 1 kg the weight on one pan, and on the other pan you will place the sugar plastic and you keep adding sugar to that. Initially you add 10 gram, 15 gram, 20 gram, 30 gram, 40 gram. You keep adding sugar. There is no changes happening in the particular instrument. And you are supposed to measure a weight of 1 kg because your weighing pan is kept with the weight of 1 kg load. Now you keep adding load, you keep adding load. At some particular point, you can see that the instrument is starting to move slowly. Okay, or you can see the pointer is moving slowly. Okay, that happens when you keep on adding weight or you keep on adding sugar, and at some particular point when you add a bit of sugar, you can see that sudden there is a change in that instrument. It start moving. That change is called as resolution. So resolution means it is the smallest change value of input that the instrument produces an observable change in the output. Now let us discuss on static and dynamic characteristics. What is static characteristics and dynamic characteristics? As the name suggests, static means it is a state of rest and dynamic means it is a state of motion. So here also static and dynamic characteristics meaning will remain the same. Static characteristics means they are the values given when steady state is reached. Then what is steady state? Steady state is that state where the transducer has settled down after having received some input signal. Okay. So static characteristics means we are going to calculate the values or you are going to take the values when steady state is reached. And what is steady state? Steady state is a point where the values are almost fixed or the values are stagnant. Then we call it as a steady state. Dynamic characteristics, it refers to the behavior between the time that the input value changes and the time that the value given by the transducer settles down to a steady state value. So the gap between the time you put an input to the time it goes to settle to a steady state value, that time whatever characteristics we take into consideration is called as dynamic characteristics. Now, in static and dynamic characteristics, we have certain terminologies which we are supposed to understand. The first one is called as the response time. This is the time which elapses after a constant input. For example, a step input is applied to the transducer up to the point at which the transducer gives an output corresponding to that specified percentage. So that is called as the response time. Then what is time constant? Time constant means it is a constant value of time. What is that constant value? It is 63.2 percentage of the response time. Next we have something called as rise time. What is rise time? This is the time taken by the output to rise to some specified percentage of steady state value. So to reach steady state value, some percentage of steady state value, whatever time it takes, that we call it as the rise time. Then we have some terminology which is called as settling time. What is it? This is the time taken for the output to settle within some percentage of steady state value. So rise time means the time taken to rise and reach the steady state value, and settling time is for the steady state value to settle between some percentage of steady state value. That is called as the settling time. Now here we have an example of measuring temperature by using a temperature measuring device, and the time is given with respect to the temperature. Here the time is mentioned in seconds and temperature is mentioned in degree Celsius. Now when the time is 0, the temperature is 20. As the time increases to 30, 60, 90, the temperature has reached 39. And when it has reached 180, it has gone to 49. And as it keeps on increasing, at 300 you can see the temperature is 55, at 330 also the temperature is 55, even at 360 the temperature is 55. So what is this 55? This 55, which is a constant value, this constant value is called as the steady state value. Now in case if a question is asked to find the response time, and if the response time is given to be 95% of the steady state value, how do we calculate it? We need to calculate the 95% of the steady state value. What is steady state? 55. What is 95% of 55? That is 52.25 degree Celsius. But you don't find 52.25 degree Celsius anywhere here. You have 51 and you have 53, so it comes in between that, so it comes in between 210 and 240. So you go for interpolation and calculate the time, you get it as 228 seconds. So these type of examples are generally asked for this particular topic. Now let us go with the classification of transducer. A transducer can be classified based on the type of output it gives. That is the first classification. What output the transducer produces. On that basis, we do a classification. So, what is the classification? They are called as analog transducer and digital transducer. So, the output, if it is analog, we call it as analog transducer. If the output produced is digital, we call it as a digital transducer. Then based on the operational form, we have two types, which is called as modulating type or passive transducer. What is a passive transducer? A passive transducer is one which requires an extra or auxiliary energy source to convert energy from one domain to another. So in passive transducer, you require an extra energy source. For example, a battery has to be required for its operation. Then what is active transducer? In active transducer, which is also called as a self-generating transducer, is a transducer which requires no auxiliary energy source to convert the energy. Okay, for example, we can think of a thermocouple. You don't require an extra energy source for it to produce the output. So based on operation, we classify the transducer into two types. The one which is called as modulating type or passive transducer, and the other one is called as active transducer or self-generating type. Next, we have a classification of transducer which is called as primary and secondary. What is primary and secondary? In primary transducer, it contains mechanical as well as electrical device. It usually converts the physical quantity to be measured into a mechanical signal. Good example for that could be a thermocouple. Now what is a secondary transducer? A secondary transducer, they are deployed in cascade with the primary one. This converts that mechanical signal into more comprehensible electrical signal. Good example for that we can tell as a load cell. Thank you for your patient hearing.